What's poppin', dogs? Mr. Allen here with a little application of polynomials. We got a doozy here with the one and only Snoop Double G. So Snoop Dogg is starting a shipping company called Snoop Ships. Now, one of their shipping containers is an open top box. Perhaps they'll put like a little tarp over it, right? Maybe they're carrying mulch. I don't know. It's made from a 54-foot by 45-foot piece of sheet metal, so a flat piece of sheet metal. But they got to make a box out of this situation here, right? We want to write a volume function in terms of the height of this box made out of a flat piece of metal, all right? And then we're going to answer a few questions. So how in the heck are we going to make a box out of a flat piece of metal? Well, what we're going to do in this scenario, and it's similar in a lot of these scenarios in our little math classes, is you're going to think about, okay, well, if I were to cut out four corners here of this piece of metal, I'm going to scooch over here, there we go, cut out these four corners, and I were to fold along these dotted lines right on the inside here, I'm going to use two colors, along these dotted lines here and here, those will be pink, and then along these dotted lines here, those will be blue. That would be the rectangular base of my rectangular prism, and these edges will then fold up to create the height of the box. And what's that height going to be that would maximize the volume? That's what we're trying to figure out. Well, if I were to cut out these little corners and then fold, like you do this with like actually cardboard, I do it in my classes in with cardboard, these two dimensions would have to be the same so that the heights match up at the corners, right? And since we don't know what that is, I'll just go ahead and call it X, okay? You could call it H, you could call it X, but those two have to be the same, and it's going to be the same all the way around because I'm going to cut out the same little square so that when I fold these things up along these blue and pink lines, all the edges match up at the same height. We just don't know what that height is. We don't know what we're going to cut out, all right? So now what? Well, if I cut out X and X from 54 feet, in terms of X, wouldn't that be 54 minus 2X? Same would go over here, right? I don't need to label it twice. And then if I were to take out X and X from this 45 here, would that be 45 minus 2X? I'd say so. And then my height of this box is X. Well, a volume function, so a volume function that I would need, I could think of volume as equal to length times width times height, yeah? But I can't plug length, width, and height into my calculator. I can't math it up with three different variables. I need it in terms of one variable. This could be my length. This could be my width. The X could be my height, and now everything is in terms of X. So let's write that volume function, and then I'll put the max volume right over here. So V of X equals X, that's my height. Then I got 54 minus 2X, and I have 45 minus 2X. So there's my volume function in this particular situation, okay? Sometimes they'll give you the picture there. Sometimes they'll also describe it. And they're like, by cutting out all these corners that are the same, this, that, whatever. And they have the room for all that stuff, but I figured the diagram should help. So let's plug this into our y equals now. So we got X parentheses 54 minus 2X. And then we have 45 minus 2X. All right? So I've got that plugged in. Now, graphing this thing, usually I would just say, hey, go zoom 6. I see a blue line. That's not very helpful, right? That's really the challenge with these things is like, how do I see this graph? I have no idea what size. This would be a huge graph, okay? It's going to be in the thousands. Look, I'm asking what dimensions would yield a 6,500 cubic foot box. So the volumes would be really big. I don't even know how big. But there is a nice systematic way to do it on your T84 Plus graphing calculator. It's backwards, YORO. Anywho, and this is what I teach my students, okay? So we're going to go to our y equals again, see our function. We can also see it right here. But what are my x-intercepts here? Meaning, like, what would cause each factor to be 0, thus my volume is 0? And if you're thinking about application, do I want my volume to be 0? Do I want any of my dimensions to be 0? No. But let's find out the x-value that would do that, and we'll use that, okay? Well, 0 would make x 0. What's going to make 54 0? Half of 54 is 27. So 27 for x there. And for 45, what's half of that? 22.5. So I've got 0, I've got 27, and I have 22.5. Those are my three x-intercepts, comma 0, of course. All right, those are my three x-intercepts, or my zeros. Let's use that, okay? So go to your window. I'm going to hit 0, and my X max, I'll go to the 27 here, but you could go to the 22.5. It's really up to you. I want to see the whole graph just to talk about a few other things, okay? So now I would hit zoom fit, zoom 0, okay? Zoom 0. If you didn't know where that was, zoom. If I arrow all the way down past 9, I would see 0. Zoom fit. All right, once you get rolling on this thing, you're just going to adjust the X min and max and then hit zoom 0. It adjusts the upper and lower bounds there, the Y max and the Y min, to fit your entire graph. No more guessing and checking if you put in some logical X min and max, okay? It'll just go high to low, all right? So there we go. Now I can calculate my maximum, right? What is the max volume the box could be? Well, let's hit second and then trace, and I'm going to go to maximum. Now to get my maximum, it says left bound, okay? So I got to go to my left side of that of the maximum, the perceived maximum that I see. Hit enter, and then it says right bound. So I'm going to go to the right of it. I'm going to hit enter. We're not done yet. It says guess. Right now, you can just hit enter again. The only reason why guess is there is if there's multiple high or low points, multiple points of intersection or whatever, the calculator has you arrow close to them. We don't need to do that in this situation. So boom, I've got my maximum. It says maximum, which is, let's see here, there's an X value and there's a Y value. Well, this is a volume as a function of X. So volume is my Y value. So that means my volume is 8,818. 0.22 cubic feet. Okay. Lovely. But how about my dimensions? What are my dimensions going to be? Well, hold up. What's that X value? Well, that X value, that's my height of the box when we fold it up, right? So the height is 8.148, so 8.15 feet. That's my height, right? Well, I'll just mark that here, height. It doesn't ask for the height, but that is the height. How would I get my other two dimensions? Because we'd need 3 dimensions here for a box, right? 8.15 feet by, well, don't I have these? I've got these two right here in terms of X. If I plugged 8.15 in here, I'd get that dimension. If I plug it in here, I get that dimension. This is a rare time, guys, where I do not yo-row because I'm physically cutting out 8.15 and 8.15. What am I going to be left with? Okay? If you yo-row, I'm cool with that too. But this is actually one where I wouldn't even store my X value. I just go back to the home screen. I'd hit 54 minus 2 times 8.15. Hit enter. And I'll do the 45 right now as well. Minus 2 times 8.15. Hit enter. Those are my other two dimensions. We have 37.7 feet by 28.7 feet. Cool. Nice. All right. Got my dimensions. Make sure you include units. I got my units. That's half points, baby. That's half points. I'm going to take half points off all day if you forget your units. Don't you forget those units. All right. Part C. What is a logical domain and range of this guy? Well, my domain, let's see here. I don't want 0 for a dimension, right? And I don't want negatives for a dimension. So if I plugged in 0 here, I get 0. These guys would be fine, but I don't want 0. So I got to be bigger than 0. All right. But what do I have to be less than for my range? Sorry, for my domain. Well, if I go to 27 here, that becomes 0. So if I even did 26, this is positive. But what if I put in 26 here? It's 45 minus 52. That's no bueno. It's be a negative dimension. The upper for my domain here is actually determined by that middle guy there, 22.5. Because if I'm less than 22.5, this guy's positive, this guy's positive, and this guy's positive. If I'm greater than 0, this is positive, that's positive, that's positive, as long as I'm under that 22.5. So that's my logical domain right there, or you could say in words, 0 to 22.5 feet. All right, and how about my range now? I'll put it in a different color here. My range. Well, my range is talking about the feasible volume, which is bigger than 0, but less than my maximum right there. So from 0 to 8,818.22, that would be my logical range in the context of this problem. Now, if we're actually talking about domain and range of cubic functions, it's all real numbers for domain and all real numbers for range. But in the context of the problem, we want to keep our volume positive. So these x values, keep it positive. This y value, that's 0 to your maximum volume. It's as large as it can possibly get. Now, I'm actually going to show you a little more of this graph here, just for a teaching point, because there's a good question on a test that might be coming up, at least that I'm thinking of. Like if I were writing a test, I'd probably show something like this. Looks like my volume gets positive again. So should I say that it's positive over in that little section right there where it goes back up? No, because at that spot, these two dimensions become negative. This one's positive. A positive times a negative is not going to be a logical output here because I can't have two negative dimensions. Yes, it's going to multiply to a positive, but not real life here. I'd have negative dimensions. Not going to happen, okay? Last bit here, guys. I'm actually going to bring this window back in just a little bit. Let's go to 30. Then I'll zoom 0. All right. So the next thing here is what dimensions would yield 6,500? How do I figure that out? Well, if I hit y equals and I plug in a 6,500, then graph it. I should hit graph. Ooh, I could figure out the intersection there. And that intersection is where the volume is 6,500, which would give me an x value, which is my height, and I can plug that back in to get my other two dimensions. So let's do that. This is fun. This is a whole lot, man. This is a long problem. So second, trace. I'm going to go down to, this time, intersect. And I'm going to go over to the first one here. I'm going to get kind of close to it. So it's on the blue one, right? See how all the lettering and whatnot is blue? Hit enter. Now it all turns red. That's second curve or second line that we're working with. And then it says guess. So because I'm closer to that first intersection, it's going to go to that one, okay? So I get 3 point... and I'll do this one in pink so it'll match right now, but 3.715, so 3.72 feet. Boom, that's one of my dimensions and now I got to get my other two dimensions. So let's hit clear, and I'm going to put in 54 minus 2 times, we said 3.72, enter, and 45 minus 2 times 3.72, enter. I've got 46.56 feet by 37.56 feet. Boom. So that's one of them. But we had another point of intersection. All right, if you guys need to take a nap in the middle of this video because it's gotten kind of long, I understand. But thanks for hanging out, man. Thanks for hanging out. Let's go second trace, hit intersect once again. Now, I can actually, check this out. I could be over here. Remember we talked about that guess thing? I can hit enter twice. If I hit enter again, and it will guess, it'll go to that close one. But if I arrow closer to the other point of intersection, now it knows to choose that one, okay? So that's where the guess comes in handy. I selected my lines way away from them, but then I arrowed over for the guess. So now I've got 13.58 feet. Hopefully we're still on this screen. I made it. Okay, I got a little screen on the watch. And we're going to hit clear back to the home screen, and let's plug those in again. I wonder if I can just do this. Is this any faster? I don't know. This is probably not actually. This is totally not faster. I don't know why I arrowed back up. 0.58. That just runs the risk of making mistakes. I'm not going to do it again. Minus 2 times 13.58. I have everything. Beautiful. We have by 26.84 feet by 17.84 feet. Boom. So those are the dimensions that would yield a 6,500 cubic foot box. Two different scenarios there, two different totally different shapes that give you the same volume. I'm exhausted, guys. I'm gonna need a nap after that one. That was a lot. But a lot of stuff with the calculator there. Definitely. Make sure that you guys know that zoom fit feature. That's super helpful. And actually, I'm going to go back to the graph again real quick and adjust my window one last time here. Zoom 0. Oops. Notice how that red line passes through a third time. Is there a third set of dimensions that we could have here that would give me a 6,500 cubic foot box? Well, remember we talked about both my X and my Y's would be negative over there. Check this out, man. Check this out. And this is, again, bonus math, and we're kind of going here, but I think it'll be helpful. It's a decent thing to think about. If I arrow all the way over to that bad boy right there, and I hit enter, look at what my x value is. It's 32.2. If I plug 32 in here, that's 54 minus 64. That's a negative 10. If I plug it in here, I get another negative dimension. So that doesn't even make sense. I'm not going to say 32 by negative 10 by negative whatever. No, right? So that one does not work, okay? And I want to make a point of that because it's a great question to ask multiple choice. Like, hey, which of the following, heights would work here? Well, that one's not going to work because the other two dimensions would be negative, all right? Anywho, guys, that was a lot. Thanks for hanging out here. I appreciate it. A lot of stuff going on here with Snoop ships here, but I have a feeling this is going to be a great, shipping container made out of one sheet of 45 by 54 piece of metal, folded up, open top box. That's dope. Have a wonderful day. If you have any questions, pop them in the comments or find me in the halls if you go to school where I teach. Otherwise, deuces.